Question 7, consider this polynomial 3x to the third plus 11x squared minus 4x minus 6. Which statements are true? So the first couple that I think are the easiest to check are these two right here. Essentially, they're saying, okay, if we replace the x variable with -2, we're either going to get 22 or we're going to get positive 6. I'm definitely going to use the calculator to help me out on this one. So I'm going to type this problem in, and everywhere I see an x, I'm going to replace it with parenthesis -2. And I'm assuming I'm going to either get positive 22 or 6. I'm assuming I'm not going to, it's going to be neither one of those. Yeah, positive 22. So here's one answer. And then the next one is I want to check for the quotient of p of x and x plus 2 is one of these answers. So let's set up the problem. Let's use synthetic division. So if this is our divisor, x plus 2, x equals -2 would be the root. And the coefficients of this problem are 3, 11, -4, and -6. They go across the top. 3, 11, -4, -6. And then from here, we're going to add and multiply. So we're going to start with the 3, and we're going to add to it the number underneath the 3. There is no number underneath that 3. We can assume it's 0, although I'm not going to write it. And 3 plus 0 is just 3. And then we're going to multiply the -2 times the 3. -2 times 3 is -6. And that's going to go underneath the next coefficient, 11. And now we're going to add these two together. 11 plus -6 is 5. And then we're going to multiply these two together. -2 times 5 is -10. We're going to add these two together. We get -14. And then multiply those two together. We're going to get positive 28. And then -6 plus 28 is 22. You can see from the answer choices, these are our coefficients. 3x squared plus 5x minus 14. And then the remainder is 22. Of course, we kind of already knew that from the answer that we circled earlier. This is just another way to check it. And then that's it. The only other possible one is this one. It's saying x plus 2 is a factor of p. Remember, for something to be a factor, that means we would have to end up with a remainder of 0. And obviously, that is not the case. So we only have 2 correct answers in this problem.